Hello, everyone. Thanks for joining us for the very first episode of our Securing AI Apps on Azure series using keyless auth with Azure AI services. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours on the Microsoft Reactor YouTube channel. With that, I'll turn it over to our presenters. Thank you both so much for joining us today.
Hello, 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 everyone. Welcome to the first session of Securing AI Apps on Azure. You can see all of the sessions that are coming up in July in this list here, and you can register at this aka.ms/s-1355. I don't know if that's LEET speak for anything. Oh, like less. S less, maybe. So yeah, register for that and you'll get notified about all the ones coming up, and we're covering a lot of great topics here. So today I'm joined by Marlene. Do you want to introduce yourself?
Yeah, hi everyone. I am Marlene and I am on Pamela's team. I am a developer advocate here and at Microsoft, and I focus on Python and AI. And yeah, I've really been enjoying it so far. Big fan of keyless authentication, which we are talking about today. So yeah, I'm very active in the Python community in general.
Yeah, Marlene gives like multiple keynotes at PyCons every year. So by very active, that's very true. So I'm Pamela Fox. I am also in Python Cloud Advocacy, where our job is to help Python developers be more successful with Microsoft products, whether that's Azure or VS Code or GitHub Copilot or whatever. And it is really fun to work with all of them. And of course, for the last year, we've been working a lot with AI. So that is what we're going to be talking about today. So first, we're going to talk about key-based authentication and why we don't want to use it. This is what lots of developers use today, and maybe what you're using. And here I'm going to show an example of OpenAI, right? So the OpenAI SDK, the Python package, defaults to key-based authentication. So that's what it usually assumes people are using. And in a way that makes sense, because if you are an OpenAI.com user, like that you're using the API provided specifically by OpenAI.com, then that only supports an API key for authentication, right? So there you have to pass in a key if you're using OpenAI.com. Now for Azure OpenAI, you can pass in a key. That is one option with it. So if you're trying to use Azure OpenAI, then you pass in your Azure endpoint, your API version, and then you can pass in a key. So if you're using key-based authentication today in Python with OpenAI, your code probably looks like one of these. You might also be using a wrapper on top of the OpenAI SDK, like Langchain or LiteLLM or something like that. And similarly, they often have this way that you pass in a key. And Marlene here is going to be talking about Langchain later. So if you are a Langchain user, stay tuned for Marlene's section at second half. Now, you could also be using key-based authentication with other Azure services, right? So if you're using like Azure AI Search or Azure Key Vault would be funny. Yeah, you can use a key-based with Key Vault. Azure Document Intelligence, Azure Blob Storage. Those are all via the Azure SDK, here the Azure Python SDK, and it has this Azure key credential class. So if you're doing key-based auth with those, then you have code that looks something like this, right? You pass in a key via that key credential class. So that's what your code might be looking like if you're using key-based auth today. However, there's a lot of risks of API keys. The big obvious one is that API keys can be easily leaked. I've seen so many people put keys in PRs, and then, I help them try to get those PRs, removed from history and, taken off the web, but it's really, really hard, right? So once something gets leaked, you have to first know that it's been leaked, and then, rotate your key wherever you use it, all that stuff. So they can be leaked publicly, which is a huge risk, right? The other issue is just like internal leakage. If you're at a company and you have multiple developers across different parts of the company using keys, you might actually have multiple multiple teams using the same resource and not realizing that, and then they're like using up each other's quota and maybe causing each other like rate limit and throttling issues and not knowing it because they don't realize that they're all using the same key. And I've actually seen that happen in some pretty big companies. And so generally, like, you can run into these issues with keys, and then if you do run into them, it can be painful to rotate those keys and bring in new values for the keys and make those changes all at the same time. So there's a lot of risks of API keys. So we're trying to encourage developers to move away from API keys and instead use keyless authentication. And this is something that is possible with almost all Azure services at this point, and it's definitely possible with Azure OpenAI and other AI services. So that's what we're going to show today, is how we can go keyless. So first, I'm going to talk about how to do keyless authentication for local development. And when we talk about keyless authentication, it is based off of OAuth 2. You don't have to be an expert in OAuth 2 to use it, but it's might be helpful to know that it's based on OAuth 2. But basically, the idea is that we are, instead of using a key, we're going to get an OAuth 2 token, and that token proves we can use a resource. So in some way, we are using a key, but it's like this temporary key that expires really quickly, and that we have an existing mechanism for getting a new one up, right? So we'll get a token, we'll use that to get a resource, and it'll expire in some number of hours. We can get another token, once that one is expired. So we are still passing in a string that proves we can use a resource, but it's a token instead of a key, which means that it auto expires and that it can be refreshed easily. And so that's a real big advantage of it. So the general steps for using keyless authentication while we're doing local development is that first we have to create the Azure service, and then we need to give our own user permissions to use that service. So we give ourselves a role that says, hey, I have permission to use that Azure service. We log in to Azure locally as ourselves, our user, and then we use the Azure Identity SDK to generate either a token or a token provider, and we pass that along to the SDK for the service to prove that we can use it. So we're going to look at doing this for for Azure OpenAI. So here's the project I'm going to be using here. So if you want to follow along, you can go ahead and fork this project. It is aka.ms/azai/keyless, and it has everything set up so that we can do keyless authentication with Azure OpenAI. So first thing we need to do is create an Azure OpenAI service. If you use this project, it'll actually make it for you. But I have a few that are already made in the portal. So I'm going to go ahead and go to the portal and find an Azure OpenAI resource. I can go ahead and let me find the one that this one made. So OpenAI Keyless is the name of it. All right. So I'm just going to search for this in the portal. So I'm going to try and show you multiple ways of setting up keyless so that you can use whatever works for you. Because some people like Portal, some people like CLI. All right, so this is my Azure OpenAI resource here. So what I can do is go to Access Control and go to Add Role Assignment. So you see this Add button here. I'm going to add a role assignment. And what you can see here is this list of possible roles you can do. And this is a bunch of preset roles that correspond to like kind of usual ways of using a product. So there's this one here, which is Cognitive Services OpenAI User. And this is the one I most commonly use. Now, we can look at this role and see everything that's available to do, right? It can list operations. It can get policies for responsible AI. It can look at deployments, right? So if you want to, you can make completely custom roles that have only exactly the permissions that something needs. And that's a good way of like really, really locking something down. But a lot of times we can use these existing roles because they correspond to like a very common usage, right? So I typically use the Cognitive Services OpenAI user built-in role. And these are the permissions it has. This is what it looks like in JSON. So you can see this is what all the data actions corresponds to that it can do. And yeah, so I can go ahead and select that, right? Let's refresh that page there. I did something. I did a no. All right, so I'm going to refresh this. Okay, and then I'll just do a little filtering here so I can find it. So Cognitive Services OpenAI user. So I select that. Then I go to next. And here is where I assign it to someone. So in this case, I want to assign it to just myself, the one that's actually logged in here. So I'm going to say assign to user and select, and I find myself in here. Okay, that's myself. Great. And that looks good. Click next. I can review like, okay, I'm going to take this role and assign it to this user. So then I say review and assign. So that is how you can use the Azure portal to give access to an Azure OpenAI resource. Now, we could also use the Azure CLI. So if you like using the Azure CLI, we can do that. Let me make it so I can copy paste here. All right, so the first thing we need is we need a few things. We need our user's principal ID. That's what we call it. It's like the ID for our user. So we can say principal ID. Let me make this way bigger. Woo. Okay. Principal ID equals, and then I have to remember how to use bash. I think we go like this. There we go. Or Zush or whatever it is. Okay. So that's our principal ID. And then what else do we need? We need our subscription ID. So we'll get the subscription ID. And the way I get that one is I go to the portal, I click on subscriptions, and I can see my subscription ID here. And I'll just do like this. And then we also need a resource group. So I'm going to assign it at the resource group level. So there's different scopes you can assign these permissions at. In this case, I'm going to do it at the resource group level. You could actually do it for just the resource itself, depending on what works for you. So I'll go ahead and find the resource group that this is in. Okay, so now I've got my principal ID, my subscription ID, my resource group. Now I should be able to run this command here. And this is the AZ role assignment create command. So we say, this is the role. So this is the funky string that corresponds to Cognitive Services OpenAI user. So once you start dealing with keyless auth, you're going to see these funky strings everywhere, and they correspond to these built-in roles. And it's a nice idea to like add a comment whenever you have one of these strings so that people know, what it actually corresponds to. I have yet to memorize these. All right, and then we can run this here, and it will show us that the role is created. So that's with the Azure CLI. So that's one way you could do it. One final way you can do it is with Bicep, and this is my favorite way. As most people know, I love Bicep. So Bicep is infrastructure as code. It's similar to Terraform. If you're familiar with Terraform, the idea of Bicep is that we can declare all the resources we want to make, and we can deploy all of them together with a single step. So I really like that because a lot of my architectures are complex and made up of multiple Azure resources. And with Bicep, I can declare them all in this one place and deploy them all connected together correctly at the same time. So this is the Bicep that's inside the demo repo. So it creates a resource group. It creates an Azure OpenAI account with a single deployment in it. And here is where it makes the user. So this is my role for myself. So I set the principal ID equal to this parameter principal ID. I set the role definition ID to that magic string, which means Cognitive Services OpenAI user. And I set the principal type to user. Now this principal ID is coming from this main.parameters.json. And this comes from my AZD environment. So I always use AZD. AZD is a CLI that can deploy things based off of Bicep. So when I do AZD up, it checks to see what my logged as principal ID is, sets the principal ID parameter to it, and then sends it into the Bicep, and then that becomes the role here. So that is the third way that you can create these roles. So once we do that, we need to actually use this role-based access in our Python code. So in our Python code, what we need to do is bring in the Azure Identity SDK. This example is in Python, but I think it should hopefully be similar in other languages. So we bring in this Azure Identity SDK. We also bring in the OpenAI package because we're going to be using that. And what we do is we use this default Azure credential from the Azure AI Identity SDK. And what that does is that it actually tries multiple ways of figuring out how you're logged in. So it'll check your environment variables. It'll check to see if you're logged in with the Azure CLI. It'll check to see if you're logged in with the Azure Developer CLI, if you're logged into Azure PowerShell. There's so many ways that you can be logged into Azure, and default Azure credential will go through the chain of all those ways. You can also, if you want to, you can be really specific. Like if you know that you're always going to be logged in with the Azure CLI, you could do that. You could also do, I think it's, I don't remember how to, I think it's this maybe. So you can be really, really specific, but it's kind of convenient to not be specific and give developers more flexibility for how to log in. So so we get our credential. And then based off that credential, we get a bearer token provider. So we say, hey, we need something that's capable of giving us tokens for this OAuth scope for this credential. So this is not a token itself. This is a function that we can call to get new tokens. And the reason we want a token provider versus a token is because this is more compatible with like token refresh and token expiry. If we only got a token, that token would work the first time we got it, but then like an hour from now, it would just stop working, right? So what we do is we get a token provider, and then the OpenAI SDK can just call that token provider every time it needs a token and make sure that tokens are, up to date and they're not expired. So that's what we do is we get a bearer token provider, and it's basically a function that can be called by the OpenAI SDK. And then when we construct our OpenAI class here, we specify our endpoint, we pass in the token provider, and we do not pass in a key. So look, Ma, no keys. All right, so then let's try it out. And I can just run this code here. It looks like it's asking for a haiku. Yeah, it is. And there we go. That works. So this is what it looks like to use keyless authentication locally. I see a question from John Aziz that it doesn't work with AZD login. It does work with AZD login. That's the only way that I'm logged in right now. I actually don't usually log in with other ways. So it should certainly work with AZD login. At least the default Azure credential should work. If you look at the IntelliSense for this, it does. The very final thing it checks is the Azure Developer CLI. If you are having issues, it might be because it's getting confused by something earlier in the chain. So that is the drawback of default Azure credential, is that it can get confused by things that are earlier in the chain. So as I was saying, you have two options there. One is that you can specifically use only the type of credential that people are going to be using, right? If that's like Azure Developer CLI credential, that's a class. Or you can also do this exclude. So a lot of times I do exclude shared token cache because I know I'm never going to use that, right? There's a bunch of excludes like this. So you could do like exclude maybe environment, because I have seen people get messed up by that. So that's another option, is that so you can either be really specific. If it's not working to have it go through the whole chain, you can either explicitly exclude things that you know that you're never going to use and that are maybe problematic and tripping people up, like these two here. Or you can be really specific and say the credentials always coming from, a particular place like the Azure Developer CLI. But the thing about default Azure credential is that it's going to work a little bit better once we go into production. So yeah, you have options is the thing to know. Great question there. Okay. So that's working now. All right. So we did Bicep, we did the SDK. Now, one thing I wanted to show just as kind of a bonus thing you can do if you're getting really into keyless auth, if you're getting super excited, you're like, yes, everything's going to be keyless, no more keys anywhere. What you might want to do is actually enforce that keys can never be used with your OpenAI. And the way to do that is the very confusingly named parameter disable local auth. So when you hear this, you think, oh no, if I disable it, I'm not going to be able to use my OpenAI locally. That is not what it means. You have to think of this as like disable key-based auth. That would be a much, much better parameter name. Ignore that. It would be a much better parameter name than disable local auth. Because as you can see, I have disabled local auth true, and I just ran this, locally. So it's a weird name. I think it's because traditionally people would tend to use keys when they're developing locally. And so that's what it got called. And it got called this across multiple Azure services. So you're going to see disable local auth true in a lot of my Bicep for lots of different Azure services. But it basically means disable key-based auth. So if you do this, then no one will be able to use keys with this OpenAI resource. So that might be a good thing if you want to make sure to really lock things down. It could also be a bad thing if you do have some developers on your team that have to use keys for some reason. So you definitely want to check with your team, because I have set this to true in some of our projects and then heard from developers like, oh, unfortunately, actually, some of my people on my team need to have key-based access. So that's a team decision to make. And you can also, if your team decides like, yeah, we're on board, we don't need keys for anything, you can set a policy at the resource group level or the subscription level that says, oh, no one can have keys on their cognitive services account in this whole, resource group or sub. So that's something you can set as a policy. And there's an article about how to do that here. Okay. So now that we've seen how to do keyless auth locally, the next thing is how do we do keyless auth once our app is deployed on Azure? Right? If it's deployed on app service or container apps or Kubernetes or functions, like whatever your favorite Azure platform is. For me, it's usually container apps or app service. How can we then continue to use keyless auth in that environment? So that is going to be a little bit trickier because we need the app to have a way to identify itself and for that app to have permissions to use the OpenAI resource. So what we do is, create our Azure OpenAI service, create our, app, in this case, an Azure container app. Then we need to create an identity for that app to use. And once we've created that identity, we have to give that app identity permissions to use the OpenAI service. So similar to how we gave our own user permissions, we'll give the app identity permissions to use the OpenAI service. And then we'll use the Azure Identity SDK and make sure that it knows which app identity we're using. So for this example, here is the akka. It's akka.ms/keyless-azure-container apps. So if you want a minimal example of how to do keyless auth with Azure OpenAI and Azure Container Apps, this is the sample for you. So the first thing is that we need to have an identity for our container app. There's actually two options for kinds of identities. One is called the system identity, and the other is called the user assigned identity. Now, a system identity is one that has a one-to-one association with a container app. So it, as long as a container app is alive, if you have system identity turned on, then that system identity will be alive. But if the container app gets taken down, that system identity will not exist anymore, right? So it is very much tied to the app. And since it's a one-to-one relationship, the container app always will have this same system identity. The second option is what's called a user assigned identity. And there you create that independently of the app. And then you tell the app, hey, you can use this user assigned identity. So it has a lifetime that is independent of the app. And that can be convenient if you want to be able to use the same identity for other things as well. And you don't want it necessarily so tied exactly to the container app. And that's actually what I'm going to use in this example here. So how do you assign identity to container apps? So we're going to, once again, look at different ways of doing that. So let me go to find my container app here. So here I've already created it. And if we go into the portal and we look at identity, and what we see here is two tabs. There's the system assigned tab and then the user assigned tab. Right? So system assigned, we could just turn that on if we want to use a system identity. You can see I have it turned off because I'm not going to use it in this case, but you can just turn that on to get the system assigned identity. I'm using user assigned, and you can see that I already have it. Assigned here, and you can actually have multiple user assigned identities. So that's the interesting thing about user assigned identities is that in theory, you can actually associate your container app with multiple user assigned identities. So it's not a one-to-one relationship. It's like potentially like a many-to-many relationship actually. So you can see here, there's an add, and I could go ahead and assign another one here if I wanted to and say, oh, okay, yeah, also this one, is also an identity. And then, and then I could add that to the app. So what I'll do is just remove this one so that I can add it back and show that we can add it back. Let's see. All right, so it's taking a few seconds to remove that. You can check up here to see the activity log for when it's doing things. I don't really remember how long. Oh, there we go. Okay, so it's refreshing. It's still showing there. So we'll just go ahead and just reassign it just from here. It'll probably just let us reassign it anyway. Chat pro. No. Okay, it's not going to find it because it's still showing there. It just really wants to hold on to that. So this one I did assign using Bicep. So let's just go ahead to the Bicep because really that's how I did it anyway. So let's look at this repo here. So this is the one that I'm demonstrating right now. So what you can see in this repo is that here's the same Bicep that I showed in the local dev section where I, created the role for my own principal ID and it was a principal type user. Now, when we're doing something in, on Azure Container Apps, we're going to create a role for its identity. So I say, okay, take the ID of that I've assigned to that app, assign it the same user. You can see here that it's the same string. So this is Cognitive Services OpenAI user. And in this case, the principal type is going to be service principal. So they do have two different principal types, right? For me, it was a user for local dev, and for the deployed apps identity, it's going to be a service principal. And for this principal ID, we can take a look at how I got that. In the aka.bicep, you can see that this is how you can create a user assigned identity in Bicep. It's actually a really short amount of Bicep. You just say, I'm making a user assigned identity. This is the name for it, and here's the location. And then we just pull out the principal ID from that user assigned identity. And we also assign it to the container app. Around here is where I assign it in this Bicep. So we need to create the identity, assign it to the container app, get the principal ID from it, and then use that principal ID to assign it a role. And that sets it all up. Now, that's a lot of steps, but once you do have it working, then everything is connected. There is actually one more step, which is that we set an environment variable of Azure client ID. So you see here how I set this environment variable Azure client ID, and I set that equal to the client ID of the property. which is different from the principal ID. So we have multiple IDs, and that can be a little confusing, but we set the Azure client ID to the client ID of the property. And the reason we do this is because it's going to make it easier to use default Azure credential, because default Azure credential actually looks for Azure client ID when trying to figure out how to authenticate. So now we can go ahead and look at the actual code. So here is the code where I say, okay, I'm going to create a default Azure credential. You can see I excluded something I knew I wasn't going to use. And then I get the token provider. So I didn't have to tell it what the ID was to use, because I set Azure client ID. So if you set Azure client ID to the user assigned identity ID, then default Azure credential will just work. If you don't set it, you do need to explicitly pass it in. So you'd have to do something like this, like managed identity client ID equals, if you had it set to a different variable, you'd do something like this. So that's the tricky thing about using user assigned identities, is that, there's a many-to-many relationship between apps and user assigned identities. So default Azure credential needs to have some way of knowing which user assigned identity you're using. So you can either set it as an environment variable or pass that ID explicitly in to default Azure credential. I think it's easier just to set it as an environment variable, because then you can have the same Python code that works locally and works in production, right? So I can go ahead and run this locally here, right? So I'll go get my local. Okay, so here's my local running here. All right. And let's see how much this is. What did Maximus do? Maximus is the horse behind me right now. I don't know how much OpenAI knows about Tangled. Let's see if it makes something up. Here we go. Captain of the guard. Yeah, so Maximum likes security, and that's why he's sitting with us today. Does Maximus like security? Okay, and this is working locally. So this is using the default Azure credential locally. So it's using that user role that we set up locally. Now we can also try the same one in production. So here I've run AZD up. So all these repos, work with AZD. So I do AZD up, and that creates everything in the Bicep. So it creates a resource group, an OpenAI, a container app, a registry, a container app environment, all that stuff, and then deploys it here. So we can go and check it out in production. All right, and in this one, I'm going to talk about caterpillars. Why are swallowtail caterpillars so cute? I have a bunch of them outside on my dill right now that are really exciting. But what about their horns? Their horns are so cute. There we go. The Osmeterium. They're so adorable. Okay, so this is working in production. And we can go ahead and look at the environment variables. So if you look at the environment variables, you can see that we are specifying the Azure client ID, and this corresponds to that user assigned identity. And that's it. So we don't have to pass in any key. We just have to use the identities and the roles. And as long as everything has the right permissions, then things should work. You can go and you can inspect your identity, and you can look at its access control and see, that it has the right access control. If you're trying to debug this sort of thing, you can check all of its, permissions here. And there we go. So I think, let's see. So we talked about the portal, we talked about Bicep. And I think now we move on to Marlene to show Langchain and doing keyless auth with Langchain and other cool things. So let me go and start off with this slide, and then we'll go over to your code.
Okay, thanks, Pamela. So a lot of the things that Pamela has just presented, I will be actually putting into practice with Langchain. So Langchain is a different, it's sort of a third-party Python package. I will tell you a little bit more about it. So the code that you can see right now on the screen is basically most of the code that you can use right now. I will show some code as well that is for using Langchain with Azure, with embeddings and a retriever. But currently, we're still waiting for some PRs to be merged. So I will explain as we go along. So yeah, let's go ahead and switch to my terminal. And I will walk you through. So for anyone that doesn't know what Langchain is, I thought I would just give you a quick introduction to it. So Langchain is a Python and JavaScript framework for developing applications powered by large language models. And it aims to simplify every stage of the LLM application lifecycle. So in the development stage, it's also open source, which is great. And in the development stage, so for anyone that is actually working, let me go ahead and also increase my screen so that you can see that nicely. But for anyone actually working on building out an application, one of the nice things about Langchain is that it acts as a bit of like an abstraction. So what you're able to do is you're able to use these building blocks. So say, for example, you wanted to build a chat app that utilizes RAG, but you also wanted to be able to be really flexible with the language model that you're going to use. So maybe at some points you want to use Azure OpenAI, but other points you want to switch that out with like maybe Phi or whichever other language model that you want to use. With Langchain, the base code will remain the same, but then as you progress and when you want to switch things out, you can just change like one line of code and just replace the language model that you're going to use. So I think that's really helpful because, yeah, it kind of acts as an abstraction in that way. It also allows you to sort of productionize your app in a short space of time. So whether that's inspecting your code, monitoring and evaluating your code as well, and also the response from the LLMs, you can do that with Langchain. And then also they have a deployment thing as well, where you can turn the chains that you build in Langchain, which are just the components that you build and put together. You can turn those into APIs as well. I think it's really, particularly for me, I think the most interesting part about Langchain is the development part. So really being able to quickly take building blocks and build out sort of more complex applications in a short space of time. I think that makes it really useful. So we're going to look at two examples today in the code. And to do this, we are going to first need a couple of dependencies. For this to work, we'll need the Langchain package itself. All of this is in Python. But again, you can do this in JavaScript too. We'll also use the Langchain OpenAI package. So you'll have to install both of those. And we'll need Azure Identity, just like Pamela mentioned before, and the Azure Search Documents package as well. So those are all the dependencies that you'll need. Also, if you would like to just try and run this example, I do think we have an ACA for that. I did share, I think you can find the ACA in the links in the comments. And if you just want to run that, you should also have AZD installed. And at some point, I'm just going to update the code soon, but you should be able to run AZD up and have all the resources and keyless, because of Bicep, have keyless authentication just work. And that's one of the nice things, is that if you use AZD and Bicep together, it takes away a lot of the manual steps of doing things, which I think is really great. Again, a note on keyless authentication. If you get stuck anywhere, I think Pamela has some great writing on this, and also just this past video, this stream is great as well if you get stuck. And then you can also check out and use the Azure OpenAI keyless template too. So I've already installed these in this example. These are all of the dependencies that I mentioned at the top. So the first thing we want to do is we want to actually take a look at using Langchain in a similar way like we would with just normal Azure Chat OpenAI. And in this way, we first want to import it from Langchain. So like I mentioned before, you don't have to specifically use Azure OpenAI. You can use any other language model. But here we're importing it from the Langchain OpenAI package. We're also importing, like we saw, the default Azure credential and the get bearer token provider. So the same things that Pamela was using in her previous demos, we're using those same things here. And then we're going to pull from default Azure default credential as well. That will be what we'll be using to sort of authenticate our application. So this is the code to run it in Langchain here. The first thing we're doing is we're setting the version. We are also getting the Azure endpoint, and that you can just set in a sort of as an environment variable. And then we're passing our token provider, which here we had set our Azure credential to be the default credential. And we're also passing through that we want the cognitive services is what we want to access. And then we're also going to be passing through the Azure OpenAI deployment that we would also have been provisioned when we run AZD up. So all of these things should be provisioned in an environment, a .env file, once you run AZD up. And so we can run this, and just like we would with Azure, so we can pass it some sort of a prompt, and instead of in Azure Chat OpenAI, when we're just using that, it's slightly different. Here we use LLM invoke. So we're calling this LLM here, and this is how sort of chatting using the chat API in Langchain works. So we can just print this, which I'm just asking it to write me a haiku about tennis at Wimbledon, just because that is what is on right now. And I'm really interested in tennis. It says, grass court so pristine, Wimbledon's grand stage awaits, champions rise. And so that worked. And the response is what we can expect, even if we were just using Azure OpenAI without Langchain as well. So that's what a simple, I would say, or an initial beginner use with Langchain and Azure OpenAI looks like without keys. And then the second example I want to show is a more complex example with embeddings in Azure AI search. With this example, I do want to give a caveat here that, like I mentioned, Langchain is open source. And so we are updating it right now to make sure that it supports keyless authentication. I actually have a PR in that both Pamela and I have worked on a little bit, and hoping that that gets moved soon. And when it does, you should be able to run all of this code. At the moment, we're still waiting for the PR to get merged, but when it does, this should work. So what we want to do in this example is that we want to use the OpenAI ADA text embeddings model, and we want that to be able to take in a document and with Azure Search, create a vector store where we can give a document. The document is changed into embeddings, and then we can do some semantic similarity search on that document. And so here, how we do that is we want to import the Azure Search module from the vector stores in Langchain community. And then we're also going to import Azure OpenAI embeddings as well. So that's all we need to get this started. Again, like we saw above, we're going to set a token provider. We're going to pass through default Azure credential and cognitive services here. And that's what we're going to set for the embeddings to work. We'll also make sure that we're specifying which deployment, the OpenAI embedding deployment. And this is specifically like the deployment name that you named, that will be named for your Azure deployment. So not even though we're using the OpenAI ADA text model, that's not what we're passing here, which is a little counterintuitive, but this instead we're passing through the name of the deployment that we gave in Azure. And then the second thing we're passing through again is the endpoint and then the token provider here. And then we also can use, I need to take the default, the other thing away. But here we're going to use Azure Search, and we are instead going to pass through the Azure Search endpoint here. We're going to also specify that we're going to be using the embeddings model that we created here to be able to embed our documents once we pass those in. So that's what we're doing here. And then we are also going to be using our Azure default credential here. I think I was just like testing things out with this exclude managed identity credential, which we should not, but it should still work. So let's go ahead and run this code. And that worked. Let me just delete this here. And we will also, it'll be creating for us, Langchain will create for us a vector store, an index called Langchain Vector Demo in our vector store that we just created. So here we have the vector store ready to go to upload documents to it. And so in this cell here, we are going to import a text loader, and we're also going to import a character text splitter. And these are what we're going to use to be able to load a document up to our vector store and also split it into chunks so that it's able to, we're able to search through, and our semantic similarity search is going to return the results that we can expect. We're going to use this TXT file, which I just imported, which is just, I think, a document somewhere from the internet where the president is talking about COVID at some point a couple of years ago. And I'm not going to rerun this cell just because it will take some time for it to actually embed the document. But this is what it should look like if it was successful. So we can see that it was successful here because we can see some things output onto our screen in our terminal. And then finally here, we are going to use the Azure Search Retriever, which again, we can use with default Azure credential. And the retriever, all it does is it does that. It's another sort of component of Langchain that we can use that's part of search that we can use to retrieve documents that are related to a query. So it will go ahead and it will bring back some content. You can tell it how many documents it should return once you are doing a search. So here I will say I want the top one document. I want the first document that is the most relevant to my search. And we're also passing through, again, this is a search. This is part of the search API. And so we're going to pass through the search service name or the endpoint here. And again, we're going to specify that we want to use this index, which is the Langchain Vector Demo index that we created earlier on as well, that we specified here. And so when we run this, our retriever will be created, and we can then use this retriever to look through and run some queries, and it should give us back a document with information that's relevant. So if I press play here, and we can see we have some information, some content that is returned to us about COVID that the president has spoken about. So this is, and this in this full notebook here, we didn't use keys once, which is really good. And we were also using different available sort of APIs that Azure provides. So we used the Azure Chat OpenAI API here. We used the Azure OpenAI embeddings model here. We used Azure Search, and we also used Azure AI Search Retriever. And in all of those cases, we were still able to use our default Azure credential, we were able to not use keys. And this is sort of the ideal workflow I think that we're trying to move to, is really just allowing us, even in third-party apps, to be able to be keyless and not use to have better security in our code. So I will say that if anyone would like to use this notebook, I will have it. I think the link is somewhere in the comments, and you should be able to do that too. So thanks.
All right. Thank you, Marlene. I always like to see like an end-to-end rag there, just casually do that. Very nice. And I also love that Marlene showed that that we can use keyless auth with other services. And that's something that, we should be doing across the board when, when possible, is using keyless everywhere. And a lot of the same things, basically like everything we talked about, applies to other Azure services as well. In some ways, it's actually, OpenAI is harder because usually with OpenAI, we're using like a community SDK with it. Versus using like our official Azure SDK. So the Azure SDK actually makes it really easy. If we can switch back over to my screen, right? So if you're using just the Azure Python SDK and you have a credential, right? So we use this default Azure credential. And then with the Azure SDK, we can just set up a search client and just pass the credential directly in. So if you are using the official Azure SDKs, then it is super duper easy because you just pass in that credential and it knows everything about how to get tokens, right? It is very built into that, right? So you can see we do that for search, we do it for container, we do it for search index client. This is a data lake, which is a different kind of blob storage. We just pass in that credential. So the Azure SDK makes it really easy. And then, the same thing, we just have to make sure that we have the roles properly set up for whatever we need. So for example, for search, I actually have a few different search roles that I set up. So I have like a search reader role, which is used in some situations here. This is like, I need it for, some optional feature here. I do need a reader role. For search contrib, I only need it if you're using the user upload feature, right? So we can like optionally set up roles only when we need them. We just assign them to the principal ID of the backend, and then it will work. I've got it for computer vision, for document intelligence. So these principles apply to pretty much everything you're using. Just look for what is the role that I need to set, and who am I giving that role to? What role do I need locally? What role do I need in production? Just making sure that those are all set up. And you can always go into your portal and check the access control and see, does my user have the role I expect? Does my app have the role I expect? I will say it's definitely harder to debug this sort of keyless auth, right? Like when it's not working, I think Marlene knows, like, when it's not working, you'll get this like dreaded 401, I think, right? Yeah. And then it's like, oh, what's gone wrong? Because if it's not working, like, well, you could have a few problems. It could be that you're not actually logged into the account you think you're logged into. Like maybe you're logged into your personal account or something like that, right? So first check to see who you're logged in as. And try and check to see what kind of authentication it's using. You can usually like kind of see let me see if I can see it in the logs here, if it shows. So here you can see, actually in this case, apparently I am logged into Azure CLI. So you can see that it says that default Azure credential acquired a token from Azure CLI credential. So that would be the first thing I'd look to see, is like, where is my login status coming from? And is that where I want it to be coming from? And am I logged in correctly to that one? And then the next step is seeing, does this user or does this app identity have the access control? And that's where you can go into the portal or use the Azure CLI to check the access control and make sure that it is set up correctly and make sure it's the right role. We've certainly had a few situations where like we weren't using the right role. For example, there's another role that's Azure Cognitive Services user, which is not to be confused with Cognitive Services OpenAI user. If you did, let's see if I can get it to come up. I can't get it to come up, but if you did Cognitive Services user instead of Cognitive Services OpenAI user, it's not going to work. So that's the sort of thing to check when you're going on this debugging process here. All right, and there were a couple questions that came up as well about like the cost of this. So you should be able to create managed identities for free. So you should not incur any extra costs. As you see here, managed identities can be used at no extra cost. There are sometimes some limitations where some like a free tier of a service may not fully support managed identity. And an example is Azure AI Search supports inbound managed identity, meaning that you can authenticate keylessly. But if you need outbound, meaning that letting the search index use managed identity with another service, like with an indexer setup, like if you're trying to do like a blob indexer with your AI search, that doesn't work on the free tier. So there are a few situations like that where there's not full support for keyless auth, in certain tiers of services. But generally, you should be able to use keyless auth and not have it be a cost concern. So that should not be a blocker for adopting keyless auth. I think the blocker is more just around complexity and just getting everything set up that we talked about. And yeah, for next steps, if you want to start going keyless with Azure OpenAI, there is a great tutorial that shows how to do it in your favorite language. So we showed lots of things in Python since we're from the Python team, but we know people are developing in all sorts of languages. So we have .NET, Go. Let me show the actual code because that'll be more fun. And we've got so many options here: Azure CLI, Azure PowerShell, Bicep, Azure Portal. And then down here for the default Azure credential, we've got .NET, Go, Java, JavaScript, Python. So we're really trying to make it easier for folks to use keyless auth. And this article is about Azure OpenAI, but we're adding the same kind of articles to Azure AI Search and other services as well. So if you are having a difficult time using keyless auth in some particular service and language, do let us know, like tweet or whatever, and and we can talk to the content team about that. And then they have samples that you can get started with, right? So the ones that we showed in this presentation, but we've got other samples as well that show how to do it, on other platforms like App Service, and also other languages like JavaScript, TypeScript, C#. And we're working on Java. There's a PR to add managed identity to like Langchain for J. So that should help with the Java front. There's a lot of PRs in flight right now as we try to, get this working across all the most popular, packages for working with Azure services. So thank you, Marlene, for working on the PRs. It can be hard to change, libraries that aren't yours, right?
That's true. Hopefully soon, though. So,
yeah. So if you want to learn more about securing AI apps on Azure, these are our upcoming talks after this one. So the next 3 are going to be all about user auth. So if you want to have a user login and user log out on, next July 8th, we're going to be talking about that and showing external ID. If you're doing like a customer facing app, that should be particularly fun, but also for enterprise apps as well. We'll have another one about being able to do that locally. We'll have one about doing it for spa apps. If you're doing like a React front end, with whatever sort of back end, we'll talk about that on July 10th. Then we'll talk about data access control for RAG applications. RAG is what Marlene just showed. If you need certain users to be able to ask questions about certain documents, then you need data access control, and that's what we'll talk about there. And then finally, we'll talk about deploying an AI app to a private network on Azure. And that will incur extra costs in terms of a cost discussion. So that's definitely something you need to think about costs, but it can certainly increase your security. So there you go. Lots of stuff coming up. And yeah, just tweet or toot at us if you have any feedback.
Definitely.
Thank you, everybody, for joining us. Thank you so much to our speakers for another awesome session, first of a great series. You can learn more about this series at the URL at the bottom of the screen. Register for upcoming episodes. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23010. We'll see you at the next one.